Okay, the second section of Unit 2 is logarithmic functions and their graphs. And once again, I will show you in live lessons how to graph these in a little bit more detail. So in exponential form, you have the base raised to an exponent is equal to a value. So for example, I would have something like this. 5 is my base, 2 is my exponent, and then the value of that would be 25. If I want to rewrite that in logarithmic form, it'd be log base. My base is 5. So 5 is a subscript. The value is this 25. And my exponent is 2. So writing exponential form and writing logarithmic form is going to help you solve equations later on. A common logarithm has a base 10. So for example, log base 10 is usually not written because it's common of 100 is going to equal 2. And that's because 10 to the second power is equal to 100. So if you don't see the base written, it's an understood 10. Natural logarithm has a base of e. Like I said before, e is a constant. It's the value about 2.7. And it's used a lot in calculus. So if I had something like this, natural log of e to the third power, that's the same thing as saying log base e of e to the third power, which is going to equal 3, because e to the third power equals e to the third power. And I'll explain this more in detail. Every logarithmic function has a vertical asymptote, and the domain is going to be all real numbers to the right or to the left of this vertical asymptote. So if I have a function with a vertical asymptote here, and the graph looks like that, the domain is going to be x greater than whatever that vertical asymptote is, not equal to, just greater. If my vertical asymptote is here, and I graph my logarithmic function in this direction, then it's going to be x is less than whatever my vertical asymptote is. And no matter what, the range is going to be all real numbers. This goes down forever and it goes up forever. Every logarithmic function has one vertical asymptote. So the parent function is always going to be x equals 0. And then if the function moves left to right, the vertical asymptote is going to move left to right. If the function reflects, or if it moves up or down, that will not affect the vertical asymptote. And once again, just like exponential functions, we're only going to deal with translations and reflections. If you see the c value, a number with x, it's moving right or left. If you see the c value outside of the x, this is not attached. Don't put parentheses if there's not parentheses there. This sometimes is going to be written like this. F of x equals c plus log of x. And that just means it's going to move up or down. Just like every other time, if you change the y value, it's a reflection over the x-axis. If you change the x value, it's going to be a reflection over the y-axis.